In this video, I'm going to explain about the XML. XML, which stands for Extensible Markup Language, was designed with storage and transportation of data in mind. XML was designed to be both human and machine readable, although it is not as human readable as YAML or YAML. XML is often used in machine-to-machine interaction. It is software and hardware independent. In this example, you can see that XML resembles HTTP, as it has a hierarchical format. Unlike HTTP tags, however, XML tags are not predefined but are authored by the creator of an XML file. Actually, this is an XML document, The first line of this XML document indicates the XML version and data encoding being used. XML version here is 1.0, and as you can see, encoding is UTF-8, and actually encoding is the process of converting characters to their binary equivalent, in this case UTF-8. XML documents are formed as trees. An XML tree starts at a top element called the root element. All elements can have child elements. The relationship between elements can be described as follows: parent, child, and sibling. Parent is an element one level above in the hierarchy, child an element one level below in the hierarchy, and sibling an element on the same level in the hierarchy. Here you can see the XML root hierarchy. As you can see here, we have root and then child of the root, and here we have two siblings, sibling 1 and sibling 2. XML elements are formed using case-sensitive tags that occur in pairs, as you can see here. There must be an opening tag which starts with for example, this value lower than, and after that, as you can see, and the closing tag which start with again lower than, and then for example a slash. Actually, this start the root and this finish the root. Again, this start the child of root and this finish the child of root. Again, this start the sibling and this finish the sibling 1. This is the, for example, hierarchy of the XML. Each XML element can contain data between the opening and closing tags. Actually, in this example, you can see that the IP address of 10.0.0.1 is associated with the address tag, and you can see a description. Here we have interface, and then address. Actually, the address and description are sibling, and here you can see address 10.0.0.1, and this finish the address, and then description. The description is test interface, and this again finish the description, and also here you can see that it finishes the interface. In XML, spacing is not important because the parser is guided by the tag. Also, XML tags can have attributes that indicate properties. As you can see in this example, an interface can have multiple types. The first interface in this example is of type of VLAN and has the number 90, and the second interface is the physical interface, and actually this is the physical interface numbered 1/1. As you can see here, and attributes must always be quoted. Alright, as previously mentioned, XML tags are not predefined but authored by the creator of a document. When you add together XML documents from different sources, it is possible for names to collide because they use the same tags to refer to different objects. See this example. In this example, the solution to this issue is to use XML namespaces. An XML namespace is a collection of XML elements identified by a resource identifier. This identifier provides a way of distinguishing between elements of the same name, thus avoiding naming conflicts. This is the XML name collision. For example, here we have network interface, and then interface type, address, description, and here in the communication interface, again we have interface, okay, for example protocol, and then address. Here as you can see we have XML name collision. This interface is the network interface, and this interface is the communication interface. You can define namespaces explicitly or implicitly. When you define a namespace explicitly, you must prefix every element. In this example, you can see that the address and description are prefixed with if. This is the XML explicit namespace definition. Here you can see if and then the interface, again if, address, and again if. And actually here we prefixed the address and description with if. If all the elements in an XML document refer to the same namespace, you can simply use the implicit format you can see in this example. In this case, prefixes is no longer necessary. Alright, we have looked at how an XML document is formatted, but we have not talked about how to verify that a document is well formed according to a specification. This is where document type definitions DTDs and schemas with XML schema definitions XSD come in. XML schemas are preferred over DTDs because they are written in XML. They support data types and they are extensible. Therefore, we don't really talk about DTDs here. Schemas help independent people agree on a data format and verify XML data, and they can be sent along with XML file as format descriptors. Schemas provide a data modeling language for XML. This example shows the format of an XML schema. The XML document in this example, interface.xml, has two attributes on the interface elements. The first attribute, which starts with XMLNS XSI, this, okay, has two, actually informs the parser that this XML should be validated against a schema. The second attribute tells the parser where to find the schema. The schema starts with the XS : schema tag using the standard URI followed by the document schema. The first element is interfaces, as you can see here, which is a complex type because it contains other elements. It is followed by interface, which is also a complex type with child elements. Upon receiving an XML document, a common task is to extract specific information from it. There are many ways of doing this, and two important tools to have in mind are XPath and XQuery. XPath is a query language for XML document that makes gathering specific fields easy. And XQuery is a functional programming language that can be used to extract or manipulate data from XML document. It is sometimes seen as a superset of XPath. With this example, say that you would like to retrieve only the IP addresses. The following XPath expression would allow you to do this: //address. You would get the following result from running this query. Okay, this is the result. And here, in this case, you would only need the IP addresses. So you could instead run the following query: //address /text, and then here you would get the following result from running this XQuery. Also note that an in-depth discussion of XPath and XQuery is beyond the scope of this class. However, you should keep in mind that they are very useful tools for extracting information from XML documents.